I am a student of class 12th. I recently came across this book called Black Hole by the astrophysicist Brian Cox. It was talking about Penrose diagrams, black holes and white holes. Can you please explain this in a simple way? Okay, let's see what a Penrose diagram looks like. Penrose diagram. Okay, Penrose diagram. Let's put that on the screen. Let's put that on the screen. Penrose diagrams. What are these Penrose diagrams? That's a question. Here we have a Penrose diagram. Shall we make this larger? Okay, I'll put a larger version of this on the screen, and let's try and talk about what this is. What is a Penrose diagram? What does it do? What does it talk about? So here we have a Penrose diagram. Okay, so imagine you're trying to draw a map of the entire universe on one single piece of paper. Now we know that the observable universe is gigantic. It's got a diameter of about 93 billion light years. Enormous, right? So it is enormous. It could even be infinite, but our paper is small. Our piece of paper is small. So that's where a Penrose diagram comes in. A Penrose diagram is like a special map. And it was invented by a mathematician and physicist called Roger Penrose. And this diagram allows us to squeeze the whole universe on a single piece of paper. So here's how it works. So instead of showing actual distances like you would have on a map, I open the map all the time, right? So on a map of the earth, you actually see kilometers, right? The actual distances. So in a Penrose diagram, instead of showing those actual distances like a regular map, the Penrose diagram shows the path of light. It shows light paths. Now we know that light travels at the same speed, the speed of light. It's the speed limit in the universe. So these diagrams, Penrose diagrams, these diagrams here, they focus on how light moves through space and time. So using special mathematics, let's call it special mathematics, you can squeeze almost infinite distances into finite spaces on your paper. So you use the special mathematics to make things that are really far away appear really, really smaller. So the further an object is, the smaller it is depicted over here. And the furthest objects will fit on the edge of the diagram. So if you were to examine this diagram, you have space and time. Space is on the x-axis, time is on the y-axis, right? So time goes up from bottom to top, and space spreads out horizontally from left to right, and light rays travel at a 45-degree angle. So these diagrams are very useful for showing things like black holes and the expanding universe. It helps scientists visualize what happens to light and matter in extreme places and situations where space and time get really bendy because of the way general relativity works. So it's like taking a picture of the night sky with a camera that can see everything at the same time, even the parts of the universe that are really, really almost infinitely far away. So that's what a Penrose diagram is. Now talking about black holes. So a black hole. Imagine you have a trampoline. You know, trampoline. If you want to see what a trampoline looks like, trampoline. So let's put that on the screen. Imagine you have one of these things, a trampoline. It's that thing on which you bounce, a bouncing thing. That's a trampoline. This is a trampoline. So imagine you have a trampoline, and on that trampoline you put a football or a volleyball or some kind of ball. Okay, so the trampoline will sink down. Okay, ball on trampoline. Let's look for that on trampoline. So let's say you have a ball like this on a trampoline. I mean, it will bend down actually. So it will sink down. It will, one second, general relativity. Okay, here we have a ball on a trampoline. This is a better visualization. So if you put a ball on a trampoline, the trampoline sinks down, creating a big dip. And then if you roll a marble or a small ball near the bowling ball, it will circle before falling in. Okay, just keep that image in your mind. So that's kind of like a black hole. A black hole is a place in space where gravity is so strong that nothing can escape from it, not even light. And light is the fastest thing in the universe. Okay, so that's why they're called black, because we cannot see them. They're dark. They're not dark, they're essentially invisible because no light can come out of it. Whatever light you shine at it just sinks in, it never comes out. So black holes, how are they formed? They're formed, the black holes are formed when really big stars, much bigger than the sun, run out of fuel and collapse under their own weight, under their own gravity. And then the star's material gets squeezed into a tiny point, theoretically called a singularity, where gravity becomes incredibly super intense, and the curvature of space-time essentially becomes infinite, and even gravity becomes and the density of mass becomes infinite. And a black hole will have a boundary, and the boundary is called an event horizon. It's a point of no return. So once anything crosses that boundary, it can never come out, even light. That's a black hole. And a white hole is like a time reversed black hole. Imagine you are it's like a fountain in space. A black hole will absorb everything. A white hole just spews out matter and light, and you can never ever throw inside anything inside a white hole. And white holes come from the same mathematical equations, the Einstein field equations of general relativity that describe black holes. So if you take the equations for black holes and you flip around the time, like watching a movie backwards, you will get white holes. But white holes are theoretical objects. Black holes have been observed and discovered. White holes, we still don't have any confirmed observation of a white hole. So we don't quite know if white holes exist. Maybe they are just theoretical mathematical constructs that come out of general relativity, but maybe they are real and we still haven't found one. So that's the deal. Hopefully it's simple enough for you to understand.